So for our 3 examples on the bottom, we'll go through, and these are on the independent side of the note paper. So we're hoping they're just all different independent event questions. So the first one says 6 cards are numbered 1 to 6 and placed in a box. So you've got these 6 cards, 1 through 6 in a box. 1 card is selected at random and replaced. Another card is selected at random. So again, because you put it back, it qualifies as an independent event because it's like you look at it, put it back, and then the bag or the box is back to normal. So it says, what's the probability of selecting a 1 times what's the probability of getting a 6? So since there are 6 cards, the probability of getting any number would be the same, and it would be 1/6. So the probability of getting a 1 is 1/6, and the probability of getting a 6 is 1/6. Multiply the 1s and multiply the 6s, and we get 1/36. With probability, you can also put this into a percentage amount, and what you would do for that is you would divide 1 divided by 36 on your calculator, and that's the decimal of the fraction, 0.028. If I round, it would be 0.28%, making it into percentage. So that's another option for how your answer would look. You can leave it as a fraction or put it as a percentage. Next up, a coin is tossed 3 times. What's the probability the coin lands heads 3 times? So we've got 3 things going on. First, you have to flip ahead. Then you have to flip ahead. Then you have to flip ahead. So the probability you have a coin, you flip it, probability of heads and tails, always 50-50 is half. Next time, the coin forgets and you flip again and you're like, probability of heads, what is it? Half. And then you do it again, half. So every time you flip the coin, it will always be half. 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. Last, 10 numbers are numbered 1 through 10, or 10 cards are numbered 1 through 10 and placed in a box. 1 card is selected at random and replaced. Another card is selected at random. What is the probability of selecting a multiple of 3 and then a multiple of 2? So probability of multiple of 3 times probability of multiple of 2. Multiple of 3 would be 3, 6, or 9. Multiple of 2 would be 2, 4, 6, 8, or 10. So this one would be 3 tenths, and this one would be 5 tenths. If we multiply across the tops, we get 15. Across the bottoms, 100th. And reduced would be, they're both divisible by 5, so it'd be 3/20ths.